So hi friends, hi students, I am your Vishal sir. Very good morning. So today we are going to continue our second part of work, energy and power. As you know, we are into the RE-NEET series, and in part 1 we discussed some concepts of work, energy, power, like what is the definition of work, what is conservative force, what is kinetic energy, what is potential energy, what is the relation between this change in potential energy and work done by conservative force, and we saw conservation of mechanical energy. Okay, so in the second part I am going to discuss about vertical circular motion, then I am going to discuss about power, and finally we are going to see some constrained motion. So without wasting time, we are going to start this lecture. Okay, let's see. So vertical circular motion, vertical circular motion. First of all, students, you should understand this, that any kind of circular motion, suppose an object is moving in a circular path. Okay, suppose there is one object which is moving in this circular path, correct? Its tangential speed is v at this point. Its tangential speed is v. So any object which is moving in a circular path, suppose the mass of the object is m. So an object which is moving in the circular path has always one acceleration which is directed towards the center of the circle. What I say? There is always one acceleration in this direction, acceleration in the direction, this acceleration towards the center of the circle, and this acceleration is called centripetal acceleration. These basic things you must be knowing. Still I am telling. This acceleration which is directed towards the center is called centripetal acceleration, and its value is v square by r, where v is the speed of the object at any point, at this point suppose, and r is the radius of this circle. R is the radius of this circle, correct? So always remember the centripetal acceleration value is v square by r, correct? So let's discuss about vertical circular motion. Means suppose there is a string and there is a ball attached at one of the end, and what you are doing, you are performing vertical circular motion. Means you are performing the circular motion of this ball on the vertical plane, not on the horizontal plane, not on the table, on the vertical plane. So we are going to see that, correct? So see, so suppose we are performing vertical circular motion. What I am saying, speed of the object, suppose this is my center of this circle and this is the thread or string to which this ball is attached. Obviously radius of this circle I will be taking r. Like at this point, if I say what are the forces acting on this ball, you will say, sir, one force is mg, one force is tension. Tension always act away from the body. So this is the ball, so tension will act away from the. Acha, what I told just now, if the object is performing circular motion, there is always one acceleration towards the center, that is centripetal acceleration. Means acceleration is in this direction, correct? So if acceleration is in this direction, what we can say, which force will be more, tension or mg? Obviously tension will be more, mg will be less. That's why acceleration is in this direction. So what we can write, net force, that is T minus mg, this is the net force, equals to mass into acceleration. Mass into acceleration, and acceleration, what I told, centripetal acceleration, v square by r. So this relation we can write. So we can see tension equals to mv square by r plus mg. This we can write. No need to remember, but understand this concept. That here someone asked what is the tension, so mv square by r plus mg. Similarly, suppose for example, if I take at different location, like for example, here, now my ball is at this point, correct? And now I want to write down the forces and all. So what I can write, this ball is of mass m, so one force will be definitely mg, downward, because mg always act downward. Tension acts away from the body, so tension will also act away from the body, so here will be tension. And as you know, there is always one acceleration towards the center. This is centripetal acceleration, correct? Now what equation we can write? What is the net force? So we have no opposing force, only T and mg are there in the downward direction. So we can write the net force, that is tension plus mg. Why I have added? Because they are both in the same direction. So this is the net force, and the net force will be equals to mass into acceleration. Acceleration is v square by r. Suppose at this point, speed is v, suppose, then we can write mv square by r. So tension here you can write mv square by r minus mg. You saw here, when the object was at the lowest point, tension was mv square by r plus mg. But at the highest point, tension is mv square by r minus mg. So one thing we can say, so you can note down, that the object is performing vertical circular motion. Tension is here at the topmost point, tension is minimum. And at the bottommost point, tension is maximum. So this point you need to remember. Now what if they give or they ask at any angle, like for example, the object was performing vertical circular motion and the object right now is at this position, making an angle theta with this line, this dotted line. The ball is here, correct? What we can write? So see, again we will write all the forces acting on the ball. So one force is mg, downward. One force is tension. Tension will always act away from the body like this. Now if I resolve this mg into two components like this, one component, see here, if we resolve mg in two components, we can see one component will be like this and one component will be like this. Definitely we can resolve any vector in its two components. So I am resolving in these two components. So what we can see, since this angle is theta and this line, this dotted line and this line is parallel, so this line will also be theta. And if this is mg, this is theta, so this component will be mg cos theta. And this component will be mg sin theta. Now if I focus on all the forces along this line, this line, the line passing through the center. If I focus on all the forces along this line passing through the center, what we can see, one force is tension and one force is mg cos theta. And one more thing, where is the acceleration of the object? Acceleration of the object is towards the center, centripetal acceleration. So acceleration is in this direction. This is centripetal acceleration. So which is more, tension or mg cos theta? Definitely tension, because acceleration is in this direction. So this side force is more. So what we can write, net force, that is tension minus mg cos theta. This is the net force, equals to mass into acceleration. So mass is m and acceleration is v square by r. What is v? Suppose here the speed of the object, the tangential speed of the object is v. The tangential speed of the object. Okay. The tangential speed of the object is v. Correct? So we can write T minus mg cos theta equals to mv square by r. So this is the basic. These basic things we should not forget. Okay. I'm not saying that you mug up this formula. You should understand the concept, how we are writing things. Correct? So, see, in the examination, what they ask now, they normally ask tension at different points. Like if the object is here, if the object is here, if the object is here, what will be the tension at different points? Correct? So see, you write down formula for tension, direct formula I am giving you. Tension equals to mu square by L minus 2mg plus 3mg cos theta. See, the object is performing vertical circular motion. The object is performing vertical circular motion. See here carefully. The object is performing vertical circular motion. Okay. You projected this ball with a speed u here at the bottom. With u speed at the bottom, the speed is u. So the ball will go here, 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 like this. They will ask that at any angle theta, what will the tension? For example, here, if the ball is here, but at any angle theta, what will the tension? Here, tension acting on the ball. So this is the formula m, that is mass of the ball. M is the mass of the ball. Correct? U is the speed at the bottom. So u square by L. L is the length of the string. So L is equals to basically radius of the circle. Correct? Minus 2mg plus 3mg cos theta. Now remember, very important thing I am telling. Theta, always you take off that position. First this line, theta will be the angle between this line and where they are asking the tension. Suppose they are asking the tension here, so you join this point to the center. This angle will be theta. For example, because many students get confused here, like they are asking in the question that at this point, when the ball reaches this point, what will the tension? So you will apply this formula. Now you tell me what theta you will take. What should be your theta? So always remember, first you make this line, this vertical line, and then you join this line. You can see the angle is theta is 90 degree. Theta is 90 degree. Correct? Similarly, suppose They ask, what is the tension here? Again, you will apply this formula. Again, you have to find theta. So, theta, how you are going to find? You draw first this vertical line like this. Next, they are asking here. So, join this. Wait, little bit. Like this. Okay. So from this line and this line, what is the angle? What is the angle? Angle is 180 degree. You can see now. Angle is 180 degree. From this line, you have to go this much there to reach here. So this angle is 180 degree. Here angle is 90 degree. This is our theta. Here this is our theta. So you should not get confused about theta. How we are taking the theta? Theta we are taking from this vertical line. Correct? Always remember. So this is the formula. This formula you need to remember. It will be highly beneficial for you. It will save your time. Tension equals to mu square by L minus 2 mg plus 3 mg cos theta. Next, see, I'll give you like some tips also later on. First, you understand this concept that suppose there is a string and a ball like this. What minimum velocity you should provide to the ball here so that it completes a full vertical circle? Correct? Then suppose I provide very less velocity. What will happen? It will go to this height. It will come down. It will oscillate. Can you feel? Like if I push it, just give it a gentle push. So it will be little disturbed. It will go like this. It will do the oscillation. It will not perform complete vertical circular motion. So in order to perform complete vertical circular motion, what should be the minimum speed? So always remember, again I am not deriving, minimum, U minimum should be under root 5 GL. This is the minimum speed. Means, or you can write, in order to perform vertical circular motion, the speed at the bottom, I am writing, the speed at the bottom should be greater than equal to under root 5 GL. Correct? So if you are giving this much speed, this object will perform complete vertical circular motion. Now what if you give speed less than this value? So see, again I am not going to the derivation, just I am revising the points. If your speed is from 0 to under root 2 GL, the object will oscillate. And if U is under root 2 GL exactly, the object will reach till theta equals to 90 degree. Means, see what I am saying. Here, what minimum speed you should provide for complete vertical circular motion? Under root 5 GL. This is the minimum requirement. But you are not giving this much. You are giving root 2 GL. Here, the speed at the bottom you are giving root 2 GL. So what will happen? It will go to theta equals to 90 degree, means the ball will reach up to this point. Correct? Means if you give root 2 GL, the ball will reach theta equals to 90 degree. Means this point. That's I have written. If your speed is greater than 0 and less than root 2 GL, okay, if you give speed more than 0 and less than root 2 GL, the object will go till here and it will oscillate like this. The object will oscillate like this. You are giving less speed. It will not perform complete vertical circular motion. So it will go there, it will come back. It will go there, it will come back. At root 2 GL, it will go here. It will come back. It will go till here. It will come back. Oscillate. It will oscillate. Now, what if the speed you give is greater than 2 GL but less than root 5 GL? What will happen? Definitely, see, but I am saying here you give at the bottom, you give some speed which is greater than root 2 GL but less than root 5 GL. So root 5 GL is required to complete the circle and root 2 GL is required to reach here. But you are giving more than root 2 GL, so it will go above this point. But you are giving less than root 5 GL, so it will not complete the circle. So what will happen? The ball will go like this, like this. And at a certain point, at any point, suppose here, at any point here, suppose the ball will reach till here. So it will go above this height. This is root 2 GL height. Means root 2 GL height means when the speed will be root 2 GL, the height it will achieve, it is here. The point it will achieve, it will be here. If you give it more than root 2 GL, it will go move further. But you are giving less than root 5 GL, so it will not complete the circle. It will fall. So the fall, the spring, this string will become slack, and this ball will fall like this. So sometimes they ask what is the angle theta, how much angle theta it will go. So it is very easy. See, you know that this tension formula, mu square by L minus 2 mg plus 3 mg cos theta. They can ask what is this theta. You know though at this point, the string becomes loose, the ball falls down. So here tension has become 0, so put 0. So 0 equals to mu square by L minus 2 mg plus 3 mg cos theta. You can put the values and get the answer. This theta, they will give the values, mass is this, speed is this. So you have to understand this. Correct? Okay. So these points are very important. Correct? See, one short trick I am giving to you. Suppose the object is performing vertical circular motion, and here they have given the speed at the bottom. Some speed they have given. Suppose the speed at the bottom is under root mgl. Correct? Always remember the trick which I am telling, shortcut which I am telling you right now. This is applicable for n greater than equal to 5. Means if they give under root 5 GL, under root 6 GL, under root 7 GL, under root 8 GL kind of thing, it should not be less than 5. So if they ask you what is the speed value here, if they ask what is the speed value, they ask when the ball will reach here, what will the speed value? Means see, when the ball will reach here, what will be the speed value? You subtract by 2. This is the trick. N minus 2. So N minus 2 GL. They will ask what is the speed at this topmost point. Again subtract 2. So N minus 2 minus 2. N minus 4 GL. N minus 4 under root N minus 4 GL. So if this under root N GL, speed at the bottom is under root N GL, you subtract 2 under root N minus 2 GL. Again you subtract 2 for the topmost point. N minus 2 minus 2, N minus 4 under root N minus 4 GL. This is the shortcut method. Otherwise you have to again write the equations and solve. They ask tension also. That if the speed is under root mgl, what is the tension here? See, if it is n, you write n plus 1 mg. The tension at the bottom will be n plus 1 mg. Now you subtract 3 from these terms. So n plus 1 minus 3 means suppose they ask what is the tension. Like here, what is the tension in the string? So you subtract 3, n plus 1 minus 3 means n minus 2 mg. Similarly, they will ask what is the tension at the topmost point. Again, you subtract 3. So n minus 2 minus 3 means n minus 5 mg. Correct? If little bit you are confused, then I will take one example. Simple only. Don't worry. Like see, suppose they have given that this is the string, this is the ball, and we are giving here speed at the bottom. Speed at the bottom is under root 7 GL. They will ask at this point, means when theta will be 90 degree, what will the speed? You subtract 2, so it will be under root 5 GL. They will ask what is the speed at the top. Again you subtract 2, so under root 3 GL. Correct? If they ask what is the tension at this point, so n is 7, n plus 1, 7 plus 1, 8 mg. Then what I told, you subtract 3 here, n plus 1 minus 3. So 7 plus 1, 8 minus 3, that is 8 minus 3, that is 5 mg. Here again you subtract 3, 5 mg minus 3, 5 minus 3, 2 mg. This is the short trick. Achha, one more thing, that the tension is maximum, I told initially only, the tension is maximum at the bottom, tension is minimum at the topmost point. So if they ask what is the difference, always remember tension maximum minus tension minimum, it always comes 6 mg. Or you can write tension maximum is at the bottom, tension at the bottom minus tension at the topmost point will always 6 mg for all the cases, any case. So you remember this. See here also tension at the bottom is 8 mg, tension at the top is 2 mg. So their difference will be 6 mg. Correct? Okay, so these things needs to be clear, because sometimes these tricks, if you know now, it will save a lot of time. Theta, like see, speed at the bottom is u, suppose this is the ball. When the ball reaches any angle theta, what will be its speed here? So formula is under root u square minus 2gl 1 minus cos theta. Correct. So if they ask what is the speed at any angle theta, trick also I told, but you should remember the concept. Like they can ask that 30 degree, 60 degree, then what to do? Correct. So velocity at any angle theta is under root u square minus 2gl 1 minus cos theta. For example, our theta is 90 degree. Theta is 90 degree. So what will v will become? Under root u square minus 2gl 1 minus cos 90. Cos 90 is 0. So u square minus 2gl. This will be the speed at this point. U square minus 2gl. Correct. So this you need to remember. The speed at any angle v equals to under root u square minus 2gl 1 minus cos theta. Okay. So if theta is 90, you put 90, cos 90 is 0, 1 minus 0 will be 0. So u 1 minus 0 will be 1, sorry, 1 minus 0 will be 1. So u square minus 2gl. Correct. For example, u they have given under root 7gl. This example I am taking. They have given under root 7gl. And they are asking what is the speed here. Where theta is 90 degree. Where theta is 90 degree. So see, speed will be inside this location. At this location they are asking. So under root u square, that is 7gl minus 2gl. So 7gl minus 2gl, that is 5gl. Correct. And this can come from that formula directly also. See, under root 7gl, here what was the speed? Under root 5gl. So that's why I say trick is also important, concept is also important. Concept is this. This you need to remember. This you need to remember. If they ask what will the speed at any angle theta, so speed will be under root u square minus 2gl 1 minus cos theta. So this is all about vertical circular motion. Next we are going to study a little about power. Power is nothing but work done divided by time. Rate of work done means how much work you are doing in how much time. Time is very important. Na? Suppose I ask you, for example, that you have to study 2 chapters. One student said, sir, I have completed. Another student also said, I also completed. But first student completed in like 30 minutes. And the second student completed in 1 day. There is difference, lot of difference. So that's why power, rate of doing work done by time, or how much energy divided by time. Energy divided by time. So if I see the unit of power, so work done or energy unit is joule per second, or we call this quantity as watt. Correct. Power has one more formula. Remember, very important. Power equals to F dot velocity. For example, sometimes they ask that force acting on the object is 2I cap plus 3J cap. And the speed velocity of the object is I cap plus J cap. What is the power? So power you will write F dot V. So do the dot product like 2I plus 3J dot velocity, that is I plus J. So it will come 2 into 1 2 plus 3 into 1 3, 5 watt. Correct. Now see, You should remember other units of power. Kilowatt, bigger unit of power. 1 kilowatt is equals to 1000 watt. Correct? Then 1 horsepower, 1 HP, 1 horsepower equals to 746 watt. Now there is a term which is called kilowatt hour. Kilowatt hour. Now what is 1 kilowatt hour? Kilowatt is basically what? Kilowatt is basically like unit of power, and hour is the unit of time. Now what is power into time? So see, power is nothing but, I told you, energy or work done by time. So power into time, from here if I cross multiply, power into time gives energy. So first of all, 1 kilowatt hour, many students confuse that it is the unit of power. No, 1 kilowatt hour is the unit of energy. It is the unit of energy. We call it as 1 unit also. 1 unit equals to 1 kilowatt hour. And how much is this energy? Always remember, this energy is nothing but 3.6 into 10 power 6 joule. Means 1 kilowatt hour or 1 unit is equals to 3.6 into 10 power 6 joule. Means you must have heard at your home your father saying that cost of electricity bill, cost of electricity, that electricity bill is like you are getting now. So cost of electricity is rupees, suppose 5 per unit. What does this mean? Means if you consume 1 unit, they will charge rupees 5. Means if you consume 1 kilowatt hour, they will consume rupees 5. They will charge rupees 5. Means if you consume 3.6 into 10 power 6 joule of energy, they will charge rupees 5. But tell me, suppose your bill is generated and bill comes out to be rupees 100. Then how much energy you have utilized? So bill is 100, cost of electricity is 5 per unit. So how many units you have consumed? So units, 100 divided by 5, that is 20 units you have consumed. And each unit is 3.6 into 10 power 6 joule. So 20 units means this much joule energy you have consumed. Correct? Okay. Let's move to the last segment, that is constrained motion. Constrained motion. Now what is constrained motion? See, like for example, here we have one pulley kind of arrangement. So I will draw with free hand only. So suppose there is pulley kind of arrangement. This is M1 suppose, and this is M2. And any one of them is heavier. Suppose M2 is heavy than M1. Correct? So what will happen? Since this is heavier, this is light, this will go down. So this will accelerate with some acceleration, A acceleration. And you know, if this goes down, this will definitely go up. If it goes down with acceleration A, definitely this will also go up with acceleration A. Correct? Same thing, like suppose I can use for velocity also. M1, M2. Same thing, same situation. M2 is greater than M1. What I'm saying, this is heavy, this is light, this will go down. Suppose at any point its speed is V. It is going down with some speed V. Definitely, you know, this will also go up with speed V. This is called constrained, restricted, means it is going with V. This will also have to go with V only. It is not like this is going like 100 meter per second and this is saying that you go with fast, I will go slow, slow. So you go with 100, I will go 10, 10. No. If it is going with 100, this will also go with 100 meter per second. If it is accelerating A, this will also accelerate by A. Now, this is one of the easiest case. Definitely, they are not going to ask this in the exam. So, there is a rule how to find. I will give another examples. There you will understand how to write this. Like if they ask now that with what velocity and acceleration they will go, you always remember that summation of t dot x or t dot a, whatever, summation of t dot a is equals to 0. Or if they have asked about velocity, you can write summation of t dot v equals to 0. Now, what is this? Summation of t dot a equals to 0 or summation of t dot v equals to 0. Means if there is acceleration question, you apply this. If there is velocity question, you apply this. Suppose there is acceleration question, what I am saying, you tell me one thing. If object is accelerating down and tension is up, what you will write if I say what is T dot A? So T dot A will be tension multiplied by acceleration multiplied by cos of angle between them. So angle, tension is up, acceleration is down, angle is 180 degree, tension and acceleration in opposite direction. So TA cos 180 degree means minus TA. Acha, if suppose tension is acting downward and acceleration is also downward, then what you will write about T dot A? You will write plus TA. This you will write in this case, this you will write in this case, plus T. Acha, if tension is like this and acceleration is like this and there is angle theta between them, then what you will write T dot A? You will write TA cos theta. Based on this, I will give two questions so that it is more clear what I am talking about. Suppose we have this kind of thing like see the diagram. Here we have mass m. Here also we have mass m. Here we have any mass, suppose, for example. Correct? This is the situation. This angle is suppose theta. This angle is also theta. What is the question? Listen the question carefully. Just two examples I will take and then I will like finish this lecture. So if I am pulling this object down, or this object is accelerating down, similarly this is also symmetrical. You can see this is symmetrical. This is also going down with a acceleration. You can see this figure is symmetrical. So what I am saying, if these two masses are going down with acceleration a, this mass and this mass is going down with acceleration a, if this is going down, definitely you know this will move up, correct? So with what acceleration it is going to move up? With what acceleration this mass is going to move up? We have to find the acceleration of this a dash. Suppose I am writing a dash, a dash, a dash. The question is find a dash. So we will use that relation, that summation of t dot x or t dot a equals to 0. Always remember. We have to remember this formula and the rest question will be easy. Achha, this is clear na? If you pull this down, this will go up. This you can feel. Now here you see on this mass, tension acts upward direction. Always I told you tension will act up and acceleration is down. So I will write minus TA because they both are in the opposite direction. Similarly for here, this is tension. Tension acts up, acceleration is down. So minus TA. For this block, see, tension acts away. So one tension, see here I can write T. Similarly, here also tension acts away. This I will write T. And acceleration is up. So T dot A. So this is T, this is acceleration, angle between them is theta. So T A dash cos theta. See, this is T, this is acceleration. So T dot A means T, acceleration is A dash, and angle between them, so cos theta. See here also, this is T, this is acceleration, angle between them is theta. So we can write minus, sorry, not minus. So plus T, acceleration is A dash, cos theta. And same thing for this thread also. So multiplied by 2. And this should be equals to 0. Always remember, summation of all T dot A should be equals to 0. So finally, 2T A dash cos theta equals to minus TA will go that side. So plus 2TA. Correct? So 2 cancel, T cancel. So A dash equals to A divided by cos theta or A sec theta. This is the answer. Means if these two objects are going down with A acceleration, this will go up with A sec theta acceleration. See here. Again I am writing, this is T, this is A. Again I am explaining, this is T, this is A. So minus TA, this is T, this is A, minus TA. This is T, this is A. So TA cos theta, TA cos theta. Again this is T, this is A dash. So T A dash cos theta. So T A dash cos theta here also, T A dash cos theta here also. So 2 times. So minus TA, that there, it will go there. So 2TA and here 2T A dash cos theta. 2T cancel, A dash equals to A by cos theta, that is A sec theta. One last example I will take and I will conclude this work, energy and power chapter. Suppose we have this kind of arrangement. So we have two masses, correct? Suppose This is mass A, this is object A, this is object B. Here we have pulleys like this. You see the arrangement? Let me draw clear, little bit clear. Or wait. I am very bad at drawing. So kindly be like, kindly hold patience. Okay, rough drawing. Try to adjust. Rough drawing. Try to adjust. Okay. So what I am saying, that suppose this object is, what is the scenario? Suppose this object is moving with v velocity. Object B. Again, understand the question. This is the arrangement they have given. This object B is moving with v velocity. With what velocity this object A will move? What will be v dash? Correct? This will move with what velocity? They could have asked velocity, they could have asked acceleration, same concept, that is summation of t dot A or summation of t dot V equals to 0. This you have to do. So see how we are going to do. First of all, try to understand the question. Here we have one pulley, here we have one pulley, here we have one pulley. This is one string. So this is one string, it is attached to this pulley, it is wrapped over here, again it is wrapped over here. See, again it is wrapped over here. Again it is going like this. Again it is going like this. So this is a single string, that you should understand. This is a single string, and what I told, same string, same tension. Same string, same tension. So see, if I write like this, for this block, tension will act away. So suppose this is T, correct? For this pulley, if I want to like tell, so for this pulley, tension will act away. So tension will act away means this will be T. Why T? Because same string. Here also tension will be T. Here also tension will be T. Tension acts away. Now if it is T, since pulley is massless, so net force on the pulley will be same. So this side it is 2T, T plus T, 2T. So this side it should be how much? 2T. This should all, this place here also tension should be, see, I am drawing. Here tension will act away now. Here there is different string. Here this is different string. Okay. And here this tension will be 2T. Okay. Now this is T. Again for this pulley. Again for this pulley, tension will act away. So this will be T. Again tension will act away. So this will be T. Now this is T. This is T. This side 2T. So this side also 2T. So this side also I am saying it will be how much? 2T. Acha, if this is T, so for this pulley, tension will act away. This will be T. And here also, this will be T. Tension acts away. Now, for this pulley, this side is 2T. So definitely this side will also be 2T. Correct. Now you check. For these two blocks, you have to write this equation, summation of T dot V equals to 0. You focus on block A. See, I am drawing for block A. This is block A. One is tension here. Tension acts away, so you will write T. See, in this wire, in this string, see, focus here. Focus here. In this, here one string is there. In this string, tension is 2T. So here you will write tension 2T and tension acts away. Correct. Similarly, if this is block B, this is 2T. This is 2T. For block B, tension will act away. So this will be what? 2T here. This wire, see this string, tension is how much? 2T. For B, tension will act away means here 2T. Similarly here, this is 2T. Correct. So what I can write, tension into net tension in block A, 2T plus 3, 2T plus T, 3T, and velocity in the same direction. Tension and velocity is here, V dash, it's in the same direction. So tension dot velocity, so direct T, this, V dash, theta is 0. For this block, if I want to write, so 2T plus 2T, 4T, this side tension is 4T, but the velocity is in this direction, tension is in this direction, velocity is in this direction. So you write minus. So minus 4TV, and the summation of T dot V should be equals to 0. So we can write 3TV dash equals to 4TV. This will go there. So T cancel. So finally V dash is coming. 4V by 3. 4V by 3. This is the answer. 4V by 3. So little bit, it might be tough for you, but you practice this kind of questions. You see the lecture once again, how I have explained. You go to laws of motion also lecture, because in laws of motion, I have told how to take tension and all. So you might be having difficulty in understanding this because you have not listened laws of motion. So you go to laws of motion lecture and see how tension are acting in pulleys and different objects. Here you have to just apply summation of T dot V or summation of T dot A, whatever is given equals to 0. So we have two blocks, we have to apply summation of T dot A or summation of T dot V equals to 0, and you will get the answer. So that's all for work, energy and power. Hope you understood most of the concepts. So work on them, revise them, memorize some of the formulas, solve questions, and like we will again continue this series. We'll take one more chapter, next chapter. Maybe it's rotation or something else. You just stay tuned and you watch each and every lecture, okay? Either in 1.5x or 2x, okay? So hope for the best. You work hard. The result will be definitely the best, okay? Thank you. Thanks a lot.